Up and running again. So here's the problems. We're going to do 9 problems, I guess. Maybe take a screenshot. Maybe that's the best way to go here. See, I think you can see them all. Yeah. Little mechanics. All right. I think each of these problems we covered today. I don't know what else we might have missed. I'm going to do them one at a time on the other whiteboard. But if you take a screenshot and you want to try them yourself first, you might be able to scan through the video. Otherwise, just do them with me. All right, so I'm going to come over here. Work on this board. We'll tackle them one at a time. And I hope that you're also looking over your last assessment, seeing what you did right, seeing what you did wrong, looking at past videos, whatever it takes to get something right. That's what you should be trying to do. I think flashcards are great, writing down a question, other side, the solution, carrying them in your pocket, you take it out, you go, whoop, oh yeah, I remember that. Starts to put it in a long-term memory. All right, so the first problem. 5 root 14 times 2 root 7 minus 3 root 2, and we're trying to learn to work with the factors. Again, something like this. If that's 5, then that's its square root, which is the distance of the side of the square. And when you square a square root, you get what's inside. Okay, and these are factors of that number. All right, so let's write this in factored form. All right, well, 14 could have been written as 5 times root 2 times root 7. Now when I multiply across, I'm going to be squaring root 7, which means I'm going to get 7. So I'm going to get 5 root 2. Root 7 times root 7 is 7 times 2. That's kind of what I'm going to get. I'm doing that multiplication. Okay, let's go try it a different way. Let's just do it in our heads. I'm going to get 5 times 7, 35 times 2, 70 root 2. Now, maybe I should write it and just rearrange. Let's put the integers together. 5 times 2. Maybe this is the best way to see it. Times root 7 times root 7 times root 2. I've got 1, 2, 3, 4, 5 factors. 1, 2, 3, 4, 5 factors. And that's 7. So that's 5 times 2 times 7 times root 2. 10 times 7, 70 root 2. Okay? So that's what you're supposed to get out of the first multiplication. 70 root 2 minus this one here is going to be rearranging it. I'm going to get 5 times root 2, and there's a root 2 over here. And there's a root 7 here, but there's a 3 here. So I don't even put the 3 there, and then the root 7. Let me count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That becomes 5 times 2 times 3 times root 7. Yes, you can see everything. 10 times 3, 30 root 7. Root 2 and root 7 are not alike. Can't add. I can't count how many things I have because they're not alike. So this is your final answer. Okay, math's a language. You're going to get this language on the midterm. See if you can read it. So we've got x equals 8 plus and minus 3i. On the midterm, it'll either come as a negative or a positive. It won't come as both because I don't know how to make the computer do that. So let's do 8 plus 3i. Subtracting 8 equals 3i. 3i comes from plus minus the square root of negative 9. That's what it comes from. So really, you're going to square both sides, right? Which means you're squaring here. Squaring a positive or a negative is a positive. Squaring a square root undoes the operation. So that's going to get you x squared minus 16x plus 64. is equal to -9. Now, if we did it from here, and I suggest you do that, square here. So x minus 8 squared equals 3i squared. That's going to get you x minus, sorry, so I'm squaring. That's going to get you, I get the marker soon, x squared minus 16x plus 9 equals 9i squared. And that's equal to x squared minus 16x plus 9 equals -9. And now we can see the equation that gets us these answers was x squared minus 16x plus 18 equals 0. That equation produces the 8 plus or minus 3i. And we're going to do that right now. Let's see if I can put in a new cartridge. Let's see if it's this one. Oh, that's it. That's the new cartridge. Okay, but we should be able to also get from here to here. So let's do that. You know, I got that later. I've got one of those later. So let's do the one that's on the board right now, which is practicing that skill. So we're going to practice the skill of solving something that can't be solved by factoring. And if you can do the quadratic formula correctly, I'll take that answer. If you remember that from Algebra 1. But I think it's better if we look at it from a conceptual standpoint. So I'm going to rename x squared plus 10x as x plus 5 squared minus 25. I mean, that's equal to that, x squared plus 10x. Do it out, you'll see it's true. And I'm going to subtract 3. I'm going to make it 0. Okay, I've got inverse operations here. I can take minus 28, bring it to the other side as positive 28. Positive 28. I won't use the plus sign next time, but I can certainly take the square root and get x plus 5 equals plus or minus the square root of 28. I can rewrite that as the square root of 4 times the square root of 7, right? Square root of 28. So final answer, x equals minus 5 plus or minus 2 root 7. And we're going to try to learn how to do that, hopefully by Friday. If not, we got the second half of the term to keep at it. Now we're going to graph an exponential function. Let's graph an exponential function. Let's look at y equals 10, 20 times 1/2 x minus 3 over 4 plus, it says 7 over there. I'm going to change that number right now to 10, to 11, to what would be good? I don't want any numbers to duplicate here. Let's change it to 5. Okay, so if you want to try that again, or just kind of watch at this stage and see if you would have done it the same way, that's fine. Okay, so I need 2 points. And the x's I'm going to use start with 3 and 7. Those are the 2 x's I want. This number tells you how much to change the first one by. All right? 5, I have exponential decay on top of 5. So all of my y values are bigger than 5. And since I'm cutting what in half, 20, I might as well get a good picture. Okay, I'm cutting it in half. And then I'm cutting 10 in half, cutting 5 in half, and eventually I'm heading to y equals 5. So if I've got y equals 5 over here underneath 20, then that's got to be 25. And it happens when x is 3. So I'm going to put 3 in. 20 to the 1/2 to the 3 minus 3 over 4 plus 5. And I'm going to do the math. 3 minus 3 is 0. 0 divided by 4 is 0. 1/2 to the 0 is 1. 1 times 20 plus 5, 25. Okay, next number I'm going to use is 7, and I'm going to do the math. I think I'm going to get 15. And I think if I use the number 7, that's going to happen. So let's use the number 7. 20, 1/2. 7 minus 3 over 4 plus 5. Well, 7 minus 3 is 4. 4 divided by 4 is 1. 1/2 to the 1 is 1/2. 1/2 times 20 is 10. Plus 5. Bingo, 15. Looks like we got what we're looking for. Okay, now I failed to put the picture and then going from the picture back to the equation. So we'll do one of those right now. So a little extra practice in here. Okay, I am going to give you one of these. It's called Name That Tune. Name that tune is y equals. All right, so over here, got a little dotted line. I'll call it -3. I haven't done a negative before, so I feel like doing a negative. We'll do growth. You know, the reason I'm picking numbers like 2005 is I hope you get a sense of time. To an amount. Let's call this 20. Okay, and over here, let's change our time to the present, 2021, and instead of 20, you know, I don't know, let's make it 80. All right, let's see what we got. So I know everything is above -3. So the question is, how far is 20 above -3? I think it's 23 units above -3. The next one isn't 23. The next one isn't 23 units. What's the next one? How big is 80 over negative? Oh, that's 83 units. That's 83 units. And I know I want 2005 to act like a 0, so I'm going to say x minus 2005. And I know how many years it is from 2005 to 220. Well, it's 16. That's that equation. All right. Then you can play it again. Look at it from the get-go. Look at the equation, look at the graph, and see if you can see where the numbers go. And then we're going to graph y equals 8 e to the x plus 4 plus 5. And I've got a table of values that I want you to memorize. E to the negative 1.1 is a third. E to the negative 0.7 is a half. E to the 0 is 1. E to the 0.7 is 2. E to the 1.1 is 3. I hope you can see the reciprocation, the negative exponent, right? We've been studying that. And what I'm suggesting is that if we make this exponent this number, we know what number we're creating. And if we make this exponent that number, we know what we're creating. So when we make it that number, we're multiplying the first number by 1. When we make the exponent that number, we're multiplying the first number by 3. Okay, so I'm going to leave that there. So I've got y equals 5. Exponential growth. What number is useful here? 0. I'm sorry, -4. I'm going to make a 0. -4. And it's not written in fraction form. If it was written in fraction form, this would be a 1, which means I'm changing by 1 unit, going up 1 to -3. I hate any numbers duplicating, but that's what we got. All right. No. I'm so used to doing those other exponentials with you. I want x plus 4 to equal 0, and I want x plus 4 to equal 1.1. Okay, so that's my fault. So what makes the next number 1.1 minus 4, which is the same thing as the opposite of 4 minus 1.1. That's an easier way to do the problem. 4 minus 3 minus 1 is 3. And if I drop down another 0.1, 2.9 is going to be the second number. Brain's getting a little tired here. So the two numbers that are important are 4 and 2.9. Oh boy, am I tired, aren't I? -4. -4. So, excuse me, having one of those moments, middle of the afternoon. I've been at it since what? 9 o'clock with you. It's almost 3. All right, so x plus 4, let's do it again, equals 0. So x equals -4. I guess I've written it there as important. And I want x plus 4 to equal 1.1. So I'm going to do -4 plus 1.1, which is -2.9. There. Whew. All right. So what am I jumping? The first one I'm going to jump 8. The next one I'm going to jump 24 because I'm going to make this e to the 1.1, which is 3. All right, we're going to do that every time. It's going to become a system. So 8 plus 5 is 13. That's what's going to happen when I use -4. So let's do it. Let's do it. Let's use -4. -4 plus 4 is 0. What is e to the 0? E to the 0 is 1. What is 8 times 1? 8. Plus 5, output 13. -4 did it. Now we're going to use -2.9. And we're going to add 4. Well, that's actually 1.1. Oh, I forgot the e. That's e to the 1.1. What is e to the 1.1? From a calculator, it's pretty close to 3. It's not exact, okay? But we're just kind of get a feel here. So it's pretty close to 3. 3 times 8, 24, plus 5 gets me 29. That's what we're going to try to learn how to do. And obviously, you got to be careful with your addition and subtraction here, or like I almost did a minute ago, make a careless error. All right, so we got 1, 2, 3, 4 more problems. And that'll be your practice going forward. And you know, most of these we weren't able to do last time, and they do take a while to learn. Maybe some of you will get them right this time. But we're going to stick with them. All these questions are coming our way. 5x squared equals 8x. Just so you know what that looks like, 5x squared, very narrow parabola. 8x is going up steeply. I got an intersection here at 0, and I got an intersection here. We're going to find out what that x is in a moment. Subtracting 8x. We have a subtraction that can be written as a product. And the product gives us information. What numbers that work? One of them could be 0, because if you put 0 in, you're going to get 0 times 5 times 0 minus 8. 5 times 0 is 0. 0 times minus 8 is 0. 0 works, and we can see that they share, you know, a coordinate at the origin. And the x value at the origin is 0. So we got one answer. I'm going to factor again. Well, 5x minus 8 could equal 0. And that's equal to 8 over 5. Let's check that answer. Let's see if 8 over 5, just a little bit to the right, a little bit bigger than 1, these intersect. So let's put 8 over 5 in here. Oh, the 5's cancel. 8 minus 8 is 0. And 0 times 8 over 5 is 0. So we got our two answers, 0 and 8 over 5. 0 and 8 over 5. Okay? All right, so that's how you do that problem. You factor it, and you look at what makes each factor 0. X squared minus 6x equals 16. Well, we got to consider whether or not we can easily write it as a product. All right, 16 factors of 16. Say, oh, 2 and 8. 2 and 8 are 6 apart. So yes, we can write it as a product. And a product highlights the critical numbers. So x could equal 8 or x could equal -2. I'm going to do it from a graphical standpoint now, because I do want you to learn how to do this before the term's out. I'm going to look at the left-hand graph as y equals x times x minus 6. It's pretty quick and easy to do that. So what does that tell me? That tells me that this parabola goes through 0 and it goes through 6. That's a 6 and that's a 0. And it's cup shape up, so it's got to look something like that. 16 is a constant. So where do I get a height of 16? We said one of our answers was 8 and the other was -2. And I hope that that's enough graphical analysis to agree. All right, so we're getting there. And I'll upload this, send it on your way. So we're going to graph y equals -2x squared. I'm going to put the plus 12x plus 3 a little bit further to the right because I actually know that that slope intercept is a part of the graph right there. If I zoomed in, that would start to look like this line. And it's cup shaped down. So I know it's doing that. So I might as well find the information that's necessary. My y-intercept is given. It's 0, 3. So that's this location, 0, 3. I have to find that vertex, and we do it by doing minus b over 2a, which in this case is -12 over 2 times -2, which is -12 over -4, which is 3. And that's a good thing, because I know that's positive x values. If I'd gotten -3, something would be inconsistent. All I got to do is find out what goes with 3. Okay, so I plug it in, that's -18. I plug it in, that's 36. I like that relationship. Plus 3, that's positive 18, plus 3, 21. Okay, that's graphed. Now, what was it in terms of graphing form? Another way to write this would have been -2x minus 3 squared plus 21. Putting it in this form is extremely helpful because I can now find the roots. I can subtract 21. I can divide by -2. I can take the plus minus square root and I can add 3. So you should probably isolate x and see if you get 21 over 2 plus minus 3. Okay, 21 divided by 2 is near 10. Square root of 10 is near 9. 3 minus 3 is near 0. And this root right here is near 0. Just as a quick approximation. All right, so that's the graphing form. I might ask you that. This is the maximum value. If I ask for the maximum value, I don't want you to say 3 comma 21. I just want you to say 21 is the max. I might ask you about range. The range of this function is all y values less than or equal to 21. You can put any x you want in here. There's no restrictions on any operation. So the domain is all real numbers. I can put any number, subtract 3, square it, multiply it times -2 and add 21. There's no restrictions. Any number works in it, but not all numbers come out of it. Numbers bigger than 21 don't come out of this calculation. Why? Because I'm minusing the squaring process. And out of the squaring process generally comes positive numbers, which means negative numbers are being added to 21, which is why the graph is coming down. All right. All right, so let's see what we got left. Must be getting close to being done. Oh yeah, absolute value. I wish I had done one today. 2, absolute value of x minus 3, but we'll get it here now. Plus 14 plus 4 greater than 19. Okay, we want to be able to sketch this. V shape up, vertex at 3, 4. And we want to know when we're bigger than 19. These y values aren't. So I'm going to get some x values that are bigger than this x and some x values that are smaller than that x, because all of these y values are bigger than that. All right, so how do we go about it? V shape up. So this is the downside. I'm going down, then up. So -2 x minus 3 plus 4 equals 19. Positive 2 x minus 3, 4 equals 19. I'm going to find those x values. I'm going to put them on a number line, and I'm going to trial and error what works. I'm going to subtract 4. 19 now becomes 50. Oh, I didn't want fraction. It doesn't matter. I'm going to divide by -2. negative 15 over 2. So now I've done the division. I'm going to add 3. 3 minus 15 over 2. I'm going to multiply everything by 2. I get 6 minus 15. Then I'm going to divide by 2. So minus 9 halves is on this side. All right, I'll take more time with it over here. So 2x minus 3 equals 15. X minus 3 equals 15 divided by 2. X equals 3 plus 15 divided by 2. I'm going to multiply everything by 2. I get 6 plus 15. Then I'm going to divide by 2. 21 over 2. And then I'm just going to do true, false, true. And I already know the answers. I already know it's true, false, true, just from what we looked at before. But put a million in here. Don't do the math. 2 times a million plus 4, bigger than 19? Yes, true. Right? And we already know if you put a 0 in, you get the y-intercept. Right? 0 is between these two numbers. So drop a 0 in and you get 10. Is 10 greater than 19? No, that's false. You get sign changes. So I hope you can write that using interval notation. Negative infinity to negative 9 halves. Union 21 halves to infinity. I guess you can see everything. All right, so I'm going to stop the video, upload it, put it on Canvas. Hope it helps you. Those questions are coming your way Friday.